Welcome back to Show Me How to Solve It channel. In this video, you will quickly master core Python concepts and apply them to practical projects. I'll guide you from printing your first line all the way up to organizing large projects. Ready? Let's go. Before we dive in, here's how these tutorials are structured. Each concept starts with a clear definition, followed by a practical code example and its output. To get the most out of this series, I recommend opening a Google Colab session so you can code along in real time. You'll find the link to Colab in the video description. And of course, grab a cup of coffee to keep things cozy. Feel free to pause the video anytime to review the code or output more closely. Take your time, practice as you go, and let's learn Python the hands-on way. Python is a high-level interpreted language. You write human-readable code, press run, and see results instantly. No compile link cycle. Its syntax emphasizes readability. Fewer braces and semicolons, more white space. Under the hood, the interpreter translates your code into bytecode, which runs on a virtual machine. This design makes Python cross-platform. The same script runs unchanged on Windows, Linux, or Mac OS. A Python program is composed of statements, executable instructions. The most basic statement is the print function, which outputs text to the console. To display text, call print. In our snippet, print hello world writes exactly hello world to the console, your first successful program. Print can take multiple arguments, like print x, y, z, and by default separates them with spaces. Variables serve as symbolic names for values stored in memory. Assignment is performed using the equal sign, and Python dynamically determines the variable's data type. In this snippet, we define 4 variables: x as an integer, pi as a float, name as a string, and is ready as a boolean, and then print them all in one statement to verify each holds the correct value. The primary built-in data types include integers for whole numbers, floating point numbers for decimal values, strings for sequences of characters, and booleans for logical true-false values. In this snippet, we create 4 variables: a as an integer, b as a float, c as a string, and d as a boolean, and then use print type to display each variable's data type. A list is an ordered, mutable collection of elements allowing insertion, removal, and iteration over its items. In our example, we added date to the fruits list and printed each fruit with a for loop. A tuple is an ordered, immutable sequence. Once defined, its contents cannot be modified. Tuples are like lists but immutable. For example, you can create a tuple of 10, 20, and those values never change. Python can optimize tuples more aggressively than lists. A dictionary is an unordered collection of key-value pairs, providing efficient lookup, insertion, and deletion of values based on unique keys. In our snippet, we updated age from 30 to 31, then printed both the name and the full dictionary. Conditional statements, if, elif, else, enable execution of code blocks based on a Boolean expressions. In this snippet, we assign score equals 85 and use an if, elif, else chain to determine the letter grade. If the score is at least 90, we give A. If it's at least 80, we give B. Otherwise, we default to C or below. Because 85 meets the second condition, grade becomes B. Finally, we use in print to interpolate our variables and display the formatted result. Score 85, grade B. A for loop iterates over the elements of a sequence or other iterable objects, executing a block of code for each element. In this snippet, we create a list of numbers, initialize total to 0, then use a for loop to add each number to total. Finally, print outputs, sum 15. A while loop repeatedly executes a block of code as long as a specified condition evaluates to true. In this example, while count is less than 3, causes Python to repeat the indented block as long as count is less than 3, printing count is 0, then count is 1 and count is 2 before the condition becomes false, and the loop ends. Functions allow encapsulation of reusable logic. Define a function using def and invoke it by its name, followed by parentheses. Here we define a function greet name to encapsulate reusable logic, then call it with different names, greet Alice and greet Bob, to produce personalized greetings. Modules and packages organize related code into separate files and directories. Use the import statement to incorporate external modules into your program. Split code into multiple files. In math utils.py, you might define the function add that adds two numbers, then import math utils file to call the add function with 3 and 4 as parameters and get 3 plus 4 equals 7 on screen. Error handling. In Python, uses try and except blocks to catch and manage exceptions, ensuring graceful program execution under error conditions. In this example, we wrap risky code in try/except. We caught zero division error and printed cannot divide by 0 instead of crashing. File input output. Operations are performed with the built-in open function, enabling reading from and writing to files on disk. Use with open function as F to write and read files. Our snippet wrote hello file into the file and then printed it back. List comprehensions provide a concise syntax for generating lists by applying an expression to each element in an iterable. In this snippet, the expression x multiplied x for x in range 10 creates a new list by squaring each number from 0 to 9 in one line, demonstrating Python's concise list comprehension syntax. The Python standard library offers a wide range of modules, such as datetime for date and time operations and JSON for data serialization. In this snippet, we import datetime from the standard library, call datetime.now function to get the current date and time as a datetime object, then use its StarOffTime method to format and print a timestamp. Classes define custom data types and encapsulate data attributes and methods, facilitating object-oriented programming paradigms. In this example, we define a class person to represent a person with attributes like name and age. The double underscore init method initializes these attributes when we create a new object. The greet method returns a message using the object's data. When we create pcall person, Charlie 22, and call pgreet, it prints, my name is Charlie and I'm 22. This demonstrates how classes let you bundle data and behavior into reusable structures. You have now established a solid understanding of Python fundamentals and are ready to apply these concepts to small projects featured on the Show Me How to Solve It channel.